Welcome to Brain Vision.
The magnitude of the gravitational force exerted on the raindrop by the Earth is given by the following equation. The gravitational force is equal to the Newton's constant times the mass of the raindrop times the mass of the Earth divided by the distance between the center of the Earth and the raindrop squared. Now note the following. The radius of the Earth is way bigger than the distance between the raindrop and the surface of the Earth. So we say that the distance between the raindrop and the surface of the Earth in this situation is negligible. So we do not need to include it in this situation. Then, by substituting the values that were given by the problem, we get the following. The gravitational force is given by 6.67 times 10 to minus 11 times 5.2 times 10 to the minus 7 times 5.98 times 10 to 24. And this whole thing is divided by the radius of the Earth of 6.38 times 10 to the 6th squared. This gives us a gravitational force with a magnitude of approximately 5.1 times 10 to the minus 6 newtons. Now, for the second item, we have to calculate what is the magnitude of the gravitational force exerted on the Earth by the mass of the raindrop. Note that the magnitude of this force would also be given by this equation. So, these two forces have the same magnitude. The only thing that changes is the direction they are pointing. So, the raindrop pulled the Earth towards it, and the Earth pulled the raindrop towards it, but with the same magnitude. Therefore, the magnitude of the gravitational force exerted on Earth by the raindrop is equal to the magnitude of the gravitational force exerted on the raindrop by the Earth, which is what we had just calculated. So let me write these superscripts for clarity. And this is approximately 5.1 times 10 to the minus 6 newtons. So it's not necessary to do the calculation again, as the only difference between these forces is their direction.